Welcome to your Houghton and Mifflin textbook correlation CD. We hope you enjoy the information this CD has to gather. Thank you. Copyright 2002.
Please select an option below.
Hello, my name is Whit. Magnetism is a type of phenomena created by magnetic fields. It's represented by an imaginary circle of electrically charged particles. When two objects are close to each other, they exhibit a force of attraction on each other. When any two objects with the same poles are near each other, they exhibit repulsion. Many metals aren't actually magnetically attractive. The Earth itself has a magnetic field brought on by its iron and nickel core. All magnets have a north and south pole. If the same poles are brought together, they push each other away. When different poles are brought together, they are attracted to each other and pulled together. There is a phenomenon known as Coulomb's force that dictates the attraction or repulsion of objects because of electric charge. Two electric charges will repel each other in a straight line to join in their centers. Strength of magnetism can be measured in units called Gauss or Tesla. The magnetic field of Earth is actually about 1,000 times weaker than a typical household magnet. An object that is a permanent magnet holds its magnetism all the time. A temporary magnet can be made by passing electricity through a coil of wire wrapped around certain metals. The object will be magnetic as long as the current is on. These types of electrically charged magnets are called electromagnets. Nearly all electronics and appliances with electric motors use magnets to generate electricity. Magnets are used to relay sound in headphones and loudspeakers. They hold your refrigerator door closed. They're used to store and read data on your computer. Magnetism is a simple force that can be used in many different ways.
Hello, my name is Zachary Stowe. I'm here to talk to you today about transformers. A transformer is a magnetically coupled circuit whose operation is governed by Faraday's law. A transformer transforms high voltage input to low voltage output. It is very useful in the fact that the voltage that comes from a power plant is way too powerful for our appliances and devices we use each and every day. A transformer uses two properties of electricity to accomplish this: magnetism and voltage field changes. A transformer works by taking the high voltage and running it through a wire wrapped around a center iron core. The fewer coils that are wrapped around the iron core, the less voltage that is outputted. The transformer on a typical street can transform 7200 volts into 220 to 240 volts. Some electrical appliances use the full 220 volts, such as washing machines and stoves, but most devices use 120 to 140 volts, such as a television. There are two different types of transformers: step up and step down. Step up transformers have a higher secondary voltage, and step down transformers have a lower secondary voltage. In an ideal transformer, the power that goes in should equal the power that goes out. This minimizes waste in electricity and decreases cost for the receiver.
Hello, I'm Casey Meadows, and I'm here to talk to you about electromagnetism. Electromagnetism is one of the four fundamental interactions of nature. Electromagnetism contains both electrical fields and magnetic fields. Both fields are simple forms of electromagnetism. Due to this relation, when an electrical field changes, it produces a magnetic field. Conversely, when a magnetic field changes, it produces an electrical field. To construct a quantitative statement to describe this effect, however, we need to somehow define how much of the magnetic field passes through the circuit. This latter problem was solved by introducing the concept of magnetic flux. The magnetic flux is related to the number of magnetic lines passing through the area bounded by the loop of the wire. The Greek symbol phi is used to represent flux. The rate of change of flux is found by dividing the change of flux, delta phi, by the time, t, required to produce this change. The process of inducing a voltage, as described in Faraday's law, is called electromagnetic induction. Electromagnetic induction is the basis for electrical generators, induction motors, and transformers. Faraday's law explains the effect of electromagnetic induction. Lenz's law goes hand in hand with Faraday's law. Lenz's law states that the direction of the induced current generated by a charging magnetic flux produces a magnetic field that opposes the charge in the original magnetic flux.